Welcome to M Health and Info, your ultimate source for all things health and wellness. Join us as we explore the latest in medical science, debunk health myths, and provide expert insights to empower you on your health and wellness journey. Hit subscribe, ring the bell, and let's explore the world of well-being together. This is M Health and Info, where knowledge meets vitality.
Cancer development, also known as oncogenesis or carcinogenesis, is a complex and multifaceted process involving various genetic, environmental, and lifestyle factors. Here's an overview of how cancer cells develop. Initiation. Cancer initiation marks the beginning of the transformation of normal cells into cancerous cells. This process is primarily driven by genetic mutations that alter the normal functioning of cellular machinery. Genetic mutations. Cancer initiation often arises from mutations in critical genes that regulate cell growth, division, and death. These mutations can be caused by various factors, including exposure to carcinogens, such as tobacco smoke, UV radiation, or chemical pollutants, or inherent defects in DNA replication and repair mechanisms. Mutations can lead to the activation of oncogenes, which promote cell proliferation, or the inactivation of tumor suppressor genes, which normally inhibit cell growth. These alterations disrupt the delicate balance of cellular processes and set the stage for further cancer development. Loss of cell cycle regulation. Mutations in key regulatory genes can disrupt the precise control of the cell cycle, leading to uncontrolled cell proliferation. Normally, cells undergo a tightly regulated series of events known as the cell cycle, which includes phases of growth, interphase, DNA replication, S phase, chromosome segregation, mitosis, and cell division, cytokinesis. Mutations in oncogenes can drive cells into a state of perpetual growth, while mutations in tumor suppressor genes can disable checkpoints that halt cell division in response to DNA damage or other abnormalities. As a result, initiated cells gain a growth advantage over their normal counterparts and begin to accumulate genetic alterations. Promotion. Cancer promotion is characterized by the expansion of initiated cells into a detectable tumor mass. During this stage, initiated cells acquire additional mutations and undergo clonal expansion, forming a localized lesion. Expansion of abnormal cells. Initiated cells undergo clonal expansion, rapidly dividing and accumulating to form a localized mass or tumor. This process is driven by the continued proliferation of genetically altered cells and is facilitated by the disruption of normal growth control mechanisms. As the tumor grows, it may acquire additional mutations that confer selective advantages, such as resistance to cell death signals or enhanced angiogenic potential. Angiogenesis. As the tumor mass expands, it outgrows its existing blood supply, leading to hypoxia, low oxygen levels, and nutrient deprivation. In response, cancer cells release pro-angiogenic factors that stimulate the formation of new blood vessels, angiogenesis, from nearby capillaries. Angiogenesis ensures adequate oxygen and nutrient delivery to the growing tumor and facilitates its continued expansion and survival. Additionally, the newly formed blood vessels provide a route for cancer cells to metastasize to distant sites in the body. Progression. Cancer progression is characterized by the acquisition of invasive and metastatic capabilities, enabling cancer cells to spread from the primary tumor site to distant organs and tissues. Invasion and metastasis. Cancer cells acquire the ability to invade surrounding tissues and penetrate into nearby blood or lymphatic vessels, a process known as intravasation. Once in the circulation, cancer cells may travel to distant sites within the body, evade immune detection, and extravasate into surrounding tissues, forming secondary tumors through a process called metastasis. Metastatic spread is a hallmark of malignant cancer and is responsible for the majority of cancer-related deaths. The metastatic process is complex and involves multiple steps, including cell detachment, migration, survival in the circulation, colonization of distant organs, and establishment of secondary tumors. Evasion of immune surveillance. Cancer cells employ various strategies to evade detection and destruction by the immune system. These include downregulation of cell surface molecules involved in immune recognition, e.g., major histocompatibility complex molecules. Secretion of immunosuppressive factors, e.g., cytokines, chemokines, and recruitment of immune-suppressive cells, e.g., regulatory T cells, myeloid-derived suppressor cells. By subverting immune surveillance, cancer cells can proliferate unchecked and establish metastatic colonies at distant sites. Maintenance. Cancer maintenance involves the establishment of a supportive microenvironment that sustains tumor growth, survival, and progression. Tumor microenvironment. The tumor microenvironment plays a crucial role in supporting cancer cell proliferation, invasion, and metastasis. It consists of various cellular components, including cancer-associated fibroblasts, immune cells, endothelial cells, and extracellular matrix proteins, as well as soluble factors such as growth factors, cytokines, and chemokines. Cancer cells interact with these stromal elements to create a niche that promotes tumor growth and survival. Additionally, the tumor microenvironment may contribute to therapeutic resistance by providing a sanctuary for cancer cells to evade the effects of chemotherapy or immunotherapy. Genetic and epigenetic changes. Cancer cells continue to undergo genetic and epigenetic alterations throughout tumor progression, leading to increased heterogeneity, adaptability, and therapeutic resistance. These changes may include additional mutations in oncogenes and tumor suppressor genes, alterations in DNA methylation and histone modifications, and changes in gene expression profiles. The dynamic nature of the cancer genome poses challenges for targeted therapies and necessitates the development of innovative treatment strategies to overcome resistance mechanisms and improve patient outcomes. Understanding the molecular and cellular mechanisms underlying cancer initiation, promotion, progression, and maintenance is critical for the development of effective prevention strategies. Early detection methods and targeted therapies aimed at disrupting key pathways involved in cancer development and progression. By unraveling the complexities of cancer biology, researchers can identify novel therapeutic targets and personalized treatment approaches that improve patient outcomes and reduce the burden of cancer worldwide.